Welcome to the Explainer. Today, we're going to talk about a hidden memory that is literally all around us. It's in your hard drive for sure, but it also helps explain the lingering effects of an economic recession. It's this one powerful concept that shows why history, the path you take, matters, and everything from machines to entire societies. So let's just start with a really simple puzzle, something you've definitely experienced but probably never even thought about. You set your thermostat to, say, 70 degrees. Now, if it turned on the second it hit 69.9 and turned off the second it hit 70.0, it would be clicking on and off constantly, right? But it doesn't do that. So why not? Well, the answer is just one word: hysteresis. It's a kind of built-in delay that's designed into the system to stop that constant nervous switching, that chatter. You can think of it as an intentional lag that's there purely to create stability. Okay, so what does that actually mean? Well, officially, hysteresis means a system's current state depends on its history. It literally lags behind what's happening to it. So with your thermostat, it behaves one way if the temperature is falling down to 70 degrees and a totally different way if it's rising up to 70 degrees. The path it takes to get there changes everything. To really wrap our heads around this, we've got to go back to where the whole idea started. We're talking 19th century physics and the study of magnetism. This is where hysteresis was first really nailed down, and honestly, it gives us the perfect mental picture of how it works. So here's what scientists noticed. When they applied a magnetic field to a piece of iron, yeah, it became magnetized. No surprise there. But, and this is the key part, when they took the field away, the iron didn't just snap back to being non-magnetic. It actually stayed magnetized. It had a memory of what just happened to it. And when you plot that relationship on a graph, you get this really distinctive shape, the hysteresis loop. In this loop, it gives us a whole new vocabulary. First, there's remnants. That's basically the amount of memory the material holds onto. Then you've got coercivity. That's how stubborn that memory is, how much of a fight it puts out before you can erase it. These two things, memory and resistance, are the whole game. And this is where it gets really useful, because we can engineer that memory for different jobs. Soft magnets have low coercivity. They're easy to magnetize and demagnetize. That's perfect for things like transformers. But hard magnets, they have high coercivity. They hold on to their memory like their life depends on it, which is exactly what you want for a hard drive or the back of your credit card. So you see, engineers have taken this, quirky physical phenomenon and turned it into an absolutely essential tool. In so many systems, hysteresis isn't some weird side effect. It's deliberately designed right in. It makes that history dependence a powerful feature, not a bug. Take electronics. A circuit called a Schmidt trigger uses two completely different thresholds. Let's say the signal has to go above 3 volts to turn on. Well, to turn back off, it doesn't just have to dip below 3. It might have to fall all the way down to, say, 2 volts. That gap between the two, that's our hysteresis. It creates a dead band that just totally ignores any little jitters or noise in the signal. And once you know what you're looking for, you start seeing this everywhere. It's in the thermostat we started with, of course. It's even in software design, like when a menu stays open for a split second after your mouse moves away, making it easier to use. It's in audio gear, the rubber in your car's tires, even in high-tech shape memory alloys used for things like dental braces. Okay, so we've talked magnets and circuits. Now, let's take this idea of history and memory and apply it to something way more complex and a lot messier: the economy. Because it turns out, hysteresis can help us understand why some economic shocks just stick around for so long. Economists use this idea to explain why a temporary shock, like a big recession, can have effects that feel permanent. For instance, a recession might cause a spike in unemployment. But even after the economy starts to recover, the unemployment rate might not go back down to where it was. It gets stuck at a new, higher level. Why? Well, maybe workers' skills got rusty, or maybe employers just get wary of hiring someone who's been out of work for a long time. The system develops a memory of high unemployment, and that memory is incredibly hard to erase. We can even see this kind of thing in financial markets. This model here shows a hysteresis loop for stock market sentiment. You get a wave of good news, and it creates a bubble. But even after that good news is long gone, the high prices can stick around. The market's collective memory, its sentiment, is lagging way behind the actual facts on the ground. And this all connects to this bigger idea called path dependence. Really, all it means is that the path you took to get where you are today actually limits your options for the future. Past events don't just fade away, they actively carve out the channels that the present has to flow through. So we've jumped from magnets to electronics to economics. Let's take a step back and see what the common thread is here. What's the fundamental grammar of memory that all these different systems seem to share? Well, it seems to come down to a few core rules. First, these systems always have more than one stable state. You can be magnetized or unmagnetized. Unemployment can be high or low. Second, it's always harder to reverse a change than it was to make it in the first place. That's our coercivity again, right? And finally, there's always some kind of internal structure that anchors the system and gives it that memory. It could be the alignment of tiny magnetic domains in steel, or it could be something like established hiring practices in an economy. And that leaves us with a final and pretty powerful question to think about. If this idea of history dependence, of memory, is a fundamental property of all kinds of complex systems, then we need to be really, really conscious of the paths we're creating right now. Because those paths and the memories they create in our systems are going to stick around for a very long time, long after we've forgotten exactly why we chose them.